We could not, with our current model, rank D versus E. Okay? Now, whenever you are using a voltage model to compare two different bulbs, in this case D and E, you pick one path that goes from one side of the battery through one bulb and another path from one side of the battery that goes through the other bulb. Okay? So in this case, the purple path would be A plus B plus D. The blue path would be A plus C plus E. And whenever I say V, I mean delta V. Just give me a break here. Now both of these paths add up to the 12 volts of the battery, and so they have to be equal to each other. Now it's just mathematics. If I have VA on both sides, I can cancel it out. Now think about what that means. That means not only do I have the same voltage along any path from one side of the battery to the other, but from any path or any point to any other point, regardless of the paths that go between them, I have the same voltage. If two paths are parallel, it's like two paths to get down to the parking lot from the M. There's one that does a switchback like this and one that goes straight down. The change in elevation is going to be the same for both. Likewise, the change in voltage is going to be the same for this path or this path, as long as they start at the same point and end at the same point. Now, if I want to compare D to E, the first thing I do is compare the other two. If I know from the current model that C is brighter than B, then that means when I compare D and E, if the inequality goes this way, it's got to go the other way to give me the equal sign. Now, 3 minutes, one more problem, the back of that same page. We could not predict what happened to bulb C. There were two changes going on at once that were fighting each other. Now in this case, I'm not comparing bulb C to another bulb, I'm comparing it to itself before the change and after the change. Before I add that wire and after I add that wire. So I only do one path, a path from one side of the battery to the other that goes through bulb C. A plus C plus E has to equal the 12 volts of the battery. I then ask, when I short out bulb B, what happens to bulb A? Well, it gets brighter. It's an indicator for the battery. More current goes through the battery. E always gets half the current through C, so whatever C does, E does. Well, in order for this to be 12 volts, these guys have to get smaller. It's a zero-sum game. One wins, the others lose. Check that your neighbor's on the bus with this, that your neighbor could use the voltage model to solve pizza problems.